Hello students, class 10 subject mathematics chapter 2 polynomials. Today we are going to start the chapter polynomial. So first of all, I would like to make clear the basic concept of this chapter. First, polynomial. Students, you have studied this topic in 9th class also. What is polynomial? Actually a polynomial px, we write in short way px. One variable x is an algebraic expression in x of the form px is equal to an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 and dot 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 means till then a2 x to the power 2 a1 x to the power 1 and a0 x to the power 0, that you know that is 1. Here an minus 1 dot dot dot, that a0 are called real numbers, and where the an not is equal to 0. Why? Because an is the highest degree. The highest power of x is in px is n. That's why an means if an is 0, it means the polynomial doesn't have the highest degree. That's why the highest power of x in px is n. Okay, which is the degree of the polynomial px. Now example, suppose 4x plus 5 and 3x minus 1. What are they? They are polynomials in the variable x. For which variable? X of degree 1. What is the degree of these? 1, because x power 1. Here also x power 1. Say the example second, x square minus 6x plus 5 and 3y square plus 4y minus 7 are polynomials in the variable y of degree 2. This, and this is variable x degree 2. Similarly, example third, 6x to the power 3 minus 4x square plus x minus under root 3 is also polynomial in variable x of degree 3. What is that? The highest power is 3, then it is degree is 3. Here highest power is 2, so degree is 2, and highest power is 1, then degree is 1. Now next you can see here the example 4, under root 2 x to the power minus 2 plus 4. Student, this is not polynomial. The power of x is minus 2, means a negative integer. If the power of any polynomial is negative integer, then it is not a polynomial because of that. Okay. Example 5, 2x to the power 1 upon 2 plus 7. This is also not polynomial. Why? Because the power or degree of x is 1 upon 2, means in fraction form, so it is not a polynomial. Means if the degree is in the negative form or degree is in fractional form, then that this algebraic expression will not be polynomial. Okay. Now hereafter we will study kinds of polynomial. How many kinds of polynomial? Very first, constant polynomial. Students, what is constant polynomial? A polynomial of degree 0 is called constant polynomial. Means if in a polynomial degree is 0, that is called constant polynomial. Example, px is equal to 5. So what is x here? Nothing. X power 0. Or fx is equal to minus 12. Many examples you can write down. So actually here we can write px is equal to 5, and what is in the here degree? What is that polynomial? X. So suppose x power 0. X power 0, that's why x power 0 means it become 1. So here only constant term, that is 5 is constant. Here minus 12 is only constant. So this is the constant polynomial, and standard form of constant polynomial we can write down as that means standard form. A x to the power 0. A means real number and x to the power 0, that anything. Here nothing, then that's why this is x power 0 means 0 1. So that's why this is called constant polynomial. Second, linear polynomial. What is linear polynomial? A polynomial of degree 1 if polynomial is having degree 1 is called a linear polynomial. Okay, it has 1 0 that we denote with alpha 1 0. Example, here px is equal to 2x minus 1, or fx, we can write down polynomial f and g anyway. So fx is equal to minus 7 plus 3, etc. So many example. Here is standard form. If you write standard form of this, then what is the standard form? Ax plus b. A is the coefficient of x, b is coefficient of constant term, and a is not 0. See, a is coefficient of x and b is coefficient of constant. And if alpha is 0 of this polynomial, means px, then alpha is equal to minus b upon a. Alpha is equal to, means 0 of this polynomial will be minus b upon a, where what is minus b? Minus b means minus constant term, and a is, b means minus constant term, and a is coefficient of x. Okay, so this is the linear polynomial detail. Now quadratic polynomial. What is quadratic polynomial? A polynomial of degree 2 is called quadratic polynomial. For example, it has two zeros, alpha and beta. Okay, so example, a px is equal to 3x square minus 11x plus 6. For fx, x to the power 2 plus 4x plus 3, etc. So many example. Here the standard form, we write ax square plus bx plus c, where a is not 0. And here alpha and beta, means x is equal to alpha and x is equal to beta, are two zeros of this polynomial px. So then the sum of its 0 will be alpha plus beta is equal to minus b upon a. Minus b upon a means minus coefficient of x upon coefficient of x square. And here product of its 0, alpha into beta, will be is equal to c upon a. C means constant term, and a means coefficient of a. C means constant term, and a means coefficient of x square. So this is the detail of quadratic polynomial. Now cubic polynomial. A polynomial of degree 3. If a polynomial is having degree 3, highest power is 3, that is called cubic polynomial. And it has 3 0, means zeros of the polynomial is indicated by the number of power, means highest degree. Here degree is 2, so 2 zeros are you can alpha and beta. Here degree is 3, so 3 0 it has. 3 0 alpha, beta and gamma. Example, px is equal to 3x power 3 plus 6x power 2 plus 3x minus 7. So standard form of cubic polynomial we write in this way: ax to the power 3 plus bx to the power 2 plus cx plus d. Here a is not equal to 0. So what is that? Here x means first alpha, first 0. X is equal to beta is second 0. And x is equal to gamma is third 0. So 3 zeros are here. Then sum of its zeros means alpha plus beta plus gamma is equal to minus b upon a. If we verify, minus b means minus coefficient of x square, and a means coefficient of x cube. The sum of the product of zeros taken 2 at time, that is called alpha into beta plus beta into gamma plus gamma into alpha, is equal to c upon a, that is coefficient of x, and a means coefficient of x cube. Okay, from here you can see. And product of its 0 means alpha into beta into gamma, all three 0, then minus d upon a. Minus d means here d is the constant term, and a means again the coefficient of x cube. Okay, so this is the means detail of term. Means we are having biquadratic polynomial also, but till cubic polynomial it is enough. Hereafter we can solve the NCERT exercise 2.1. This is very easy, nothing in this exercise. Here I am taking exercise for you. In this 2.1, students try to see. Here we have to find the 0, means we should write down number of 0. Exercise 2.1. Question 1, only it is having one question. The graph of y, px are given in this 2.0 below. For the polynomials px, find the number of zeros. So phi, how many zeros are in first figure? Do you know the x-axis is not intersected by line? It means no 0. What is that? Write down no zeros. No zeros. Here no zeros. First part. Second part. Here x-axis is intersected by the line graph. How many points? How many number? Only one. This line is crossing. Line is intersecting on x-axis only one time. So that you write here 1 0. What you write down? 1 0. Only. In third part, line is crossing. Line is intersecting at x-axis. How many? 1, 2, 3. 3 times. So right here, third answer is 3 zeros. 3 zeros. Fourth part, line is intersecting, the graph is intersected at x-axis 1 and 2. So write down 2 zeros. That 2 zeros on x-axis. Then fifth part, the x-axis is intersecting by this line, by this graph 1, 2, 3 and 4. At 4 point it is intersected. That's why 4 zeros. How many zeros for fifth part? 4 zeros. Now on fifth part, the x-axis intersected or cut 1, 2, it is touching 1 point. 1 point, second point touching here, and 3. So 1, 2, 3. That's how many zeros? 3 zeros. 3 zeros. Now exercise 2.2. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. So this question is very easy. See, first part I am doing for you. X square minus 2x minus 8. This is given polynomial. We have to find out both 0. It is having 2 0 as it is quadratic polynomial. So we have to find out 0 of this polynomial, and then we have to find the relationship between, verify the relationship between the zeros and coefficient of the polynomial. First of all, we always, in these kind of question, we should write down standard form. I am using another pen. Standard form. What is the standard form of quadratic polynomial? That is ax square plus bx plus c. Okay, this is standard form. So if you equate the standard form with the given polynomial, then what you got here means on equating. On equating. We are equating. So what is the value of a? A is equal to, here the coefficient of x square 1 and coefficient of x square a in standard form. So a is equal to 1. So write here 1. What is the value of b? C. X coefficient of x is b in standard form, and here coefficient of x is minus 2. So therefore b is equal to minus 2. C. What is the coefficient of constant term? Minus 8. So c is equal to minus 8. These are the value of a, b, c. We have obtained this value by equating the standard form of the given polynomial. Okay. Now here we will solve. Means solving for the value of zeros of quadratic polynomial. Okay, I am writing in short way QP, quadratic polynomial. So what we will do? We have to do which method? Splitting the midterm that we did. Now we can write down by splitting the midterm. Splitting the middle term. By splitting the middle term. So right here x square minus 2x minus 8. Now what is the rule? See the last number, this constant term and the coefficient of x square and coefficient of constant term. So here what is the coefficient of x term? 1, and this is 8. 8 ones are 8. It means we should know any two number, the product should be 8. Product should be 8. And this is minus. After subtraction, these numbers should be 2. Then product means if you multiply both number, then it should be 8, and after subtracting it should be 2. So what are the number? These number 4 and 2. If you multiply 4 2 are 8 and 4 minus 2 2. So that is the given condition. 4 2 are 8 and 4 minus 2 2. We want this only. After multiplying we should get 8, and after subtraction we get 2. So now put here x square minus in bracket 4x minus 2x bracket close minus 8. Because 4x minus 2x, again you got 2x. Now what to do? See, x square minus 4x minus minus plus, if you open the bracket, because of this sign will negative sign, the sign will change. So this is positive, and 2x minus 8. Now we are having here four terms, the first pair and second pair. What is common from first pair? That is x only. So what remains inside that? X minus 4. Plus what is common from second pair? That is 2. The x minus 2 4s are 8 to 4. Now x minus 4 same in one bracket, and x plus 2 in second bracket. And if you compare that 0, means then what is that? X minus 4 is equal to 0 and x plus 2 is equal to 0. It means x is equal to plus 4 if you transpose this negative 4 this side, and x is equal to minus 2. So this first value of x is called alpha. That alpha is 4, and second value is known as beta. The beta is minus 2. These are the two zeros. Now we have to verify the relationship. So what to do? See, verify. Verification. The relationship between zeros and coefficient. Okay. So what to do? I taught you the formula of that. That was the sum of the zeros, means alpha plus beta is equal to minus b upon a, sum of the zeros. So first you verify sum of the zero. So what is the alpha? Alpha is 4, put here 4, plus what is beta? Beta is minus 2, put here minus 2, is equal to minus, this is minus of b. What is the value of b? The value of b is minus 2, so put here minus 2. And what is the value of a? Value of a is 1, so write here 1. So now see, 4 plus minus 2 means 4 minus 2 is 2 only, and here minus minus plus, so that is 2 only. So this is the verified first relationship verified. This sum of the, you can write down if you get confusion, sum of the, this is sum of the zeros. Okay. Now second relationship we have to verify product of the zero. Then product of zeros Product of the zero means like alpha into beta, and alpha into beta means is equal to c upon a. That I told you relationship in basic. Alpha into beta is equal to c upon a. So what is the alpha into beta? Alpha value is 4. So write here 4. Multiply. Beta value is 2. Second 0 2, the 2 is equal to here c upon a. What is the value of c? C is minus 8. Write here minus 8. And a value, what is the value of a? 1. Right here 1. Now here 4 2s are 8, and this is minus plus minus, the minus 8 is equal to here also minus 8. So this is also verified. So we have done this question very easily. Now students, question number second part you will do yourself in homework, same, and third part also you will do in homework. Actually third part you should write in proper way. Actually this is not written in correct form. First you write in correct form. What is the correct form? 6x square, then means this is x square term, then 7x minus 7x second term, and then constant term is minus 3. Now you can solve easily in homework yourself. Now fourth part I am doing for you. 4u square plus 8u. So again we have to do first part like first part. First you write standard form. See, as I taught you now, standard form. So how we write standard form? Means a, here x is not there, this is u, so write here u square. A square plus bu, because in the place of variable we are using u, so u, and plus c. This is the standard form. Now on equating, we get a is equal to, what is the value of a? 4. B is equal to 8, because u coefficient of u 8, here coefficient of u b, so b is equal to 8. And c is equal to, what is c? C is not given in this, it means c is 0. So therefore put here 0, there is nothing. So a, b, c we got. Now solving for the value of zeros, okay, of quadratic, right here of, not for quadratic polynomial. It's very simple. So here there is no need to take a splitting midterm, because only 2 terms are there. So directly we can start 4u square plus 8u. Now dear student, what is common from this? 4u have taken common, 4 cancel, 1 power u have taken common, the second power u is left, plus here u common, and 4 divides 8, so how many times? 2 times u. Now if you take 0, then 4u is equal to 0 and comma u plus 2 is equal to also 0. So what is the u is equal to? Means 4 will go 0, that is 0 upon 4, so it is 0 only. And here u is equal to minus 2. It means alpha is equal to 0 and beta is equal to minus 2. So these are 2 zeros, 0 comma minus 2. These are 2 zeros of this quadratic polynomial. Now we will verify the relationship. Okay. So here I am verifying the relationship. See, means verify the relationship. I am not writing the whole language, only it is enough. Now we can do sum of the zeros. Sum of the zeros means alpha plus beta is equal to minus b upon a. That is the formula as I explain you. What is alpha? Alpha is 0, so put here 0. Plus beta value is minus 2, so put here minus 2. Is equal to here minus b. What is the value of b? B is 8. So first you write down this minus sign, and b value is 8. And what is the value of a? A is 4. So write here 4. Now 0 minus 2 is minus 2 only, and minus 8 upon 4, if we divide, how many times? Minus 2, 2 times, so 2. Then this is verified, means first sum of the 0 we have verified. Now product of the 0, product of the zeros, that is alpha into beta, is equal to c upon a. So what is alpha? Alpha is 0, put here 0, into beta minus 2 is equal to c. What is the value of c? 0. The value of a is 4. So 0 into minus 2, 0, and 0 divided by 4, 0. So this is also relationship verified. So we have done very easily this question, 4th part. Now I am doing the 5th part. That is also very easy. First of all, always write down the standard form. So the standard form of this, what is the standard form? A, and in the place of variable, what is variable? T. So write here t. So t square, 8e square plus bt plus c. Okay. Now on equating, we will equate. On equating, a is equal to 1, because here t square coefficient a, here is 1, and b is equal to, where is the b constant term? B. Here b coefficient of t is b, here not given, it means 0, b is equal to, and c is equal to constant term here 15, minus 15, so right here minus 15. Okay. Now we can solving for the value of zeros of quadratic polynomial. It's very easy. No need to do splitting midterm. Here directly write down t square minus 15. Now dear student, what you can write down? Because t is having a square, but 15 is not perfect square. So in that case we have to write down t square minus, we should write down under root 15 whole square. Because if you make under root 15 whole square, then under root cancel the square and 15 again left. So that's what t square minus under root 15 square. Now here we can use the identity. What identity? That identity we use a square minus b square. That you know, a minus b and a plus b. So we will write down this t minus under root 15 in one bracket, and second bracket t plus under root 15. Okay. Now here, then what is the value of t? T here, you know that minus 15 becomes that side under plus under root 15. Under 15. And second value of t will be minus under root 15. It means alpha is equal to first 0 of this under root 15 plus under root 15, and beta value second 0 of this minus under root 15. Now we have to we have to verify the relationship. The verification. Verify the relationship between 0 and coefficient. I am writing in short way because we don't have time to write whole language. Okay, relationship between 0 and coefficient. So first to write down alpha plus beta. Alpha plus beta is equal to minus b upon a. And what is alpha value here? Under root 15. So write under root 15. See. And plus, what is the value of beta? Minus under root 15. Then minus under root 15 is equal to what is the value of b? That b value is 0. So write here 0. Minus 0 upon a value is 1. Here plus 15, the plus under root 15, minus under root 15 cancel, 0. And here also 0. So that's first relationship is verified. Now second, product of the 0 means alpha. Now alpha into beta is equal to c upon a. So what is the value of alpha? Alpha is under root 15 plus under root 15. Multiply beta minus under root 15, then minus under root 15 is equal to what is the value of c? C is minus 15. Minus 15. A value is 1. Write 1. Then see, under root 15, 15, and minus plus minus, so minus 15, and here already minus 15 is written. So this relationship also done. After that, question number 2. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. Means here first part, this is 1 upon 4 means this is sum of the 0. Okay, this is not alpha. And minus 1 is product of the 0. So first write properly. Means this is given the sum of the zeros is equal to 1 upon 4. And this is the product of the zeros is equal to minus 1. Okay. Now we want to form polynomial, quadratic polynomial. So what we write down here means we write down the required polynomial. See, the required polynomial is equal to, see, write down the formula always. What is the formula of this? This is x square minus, in bracket, the sum of zeros x, and plus the product of the 0, the product of zeros. Okay, so we will apply this formula. Then what we notice here, what is equal to, what is this? X square is x square only, okay, minus the sum of the zeros. What is the sum of 0? 1 upon 4. So write here 1 upon 4, okay, x plus the product of the 0 minus 1. The product of the 0 write down minus 1, okay. Now write in proper manner. This is x square minus x, x 1 is x, and 4, and minus plus minus 1. Actually this is required polynomial, but we know that any other quadratic polynomial that fits means any other quadratic polynomial which fits the given condition, is, what is that? Always write this k and in bracket write this whole x square minus x upon 4 minus 1. Now what is the k here? K remains for that the real number, you know, where k right here only k is real number. So we can write this in proper form. So what is the, if you take LCM, then what will come here? You can take LCM, that is 4. So right here means 4x square minus x and minus 4 1 ja 4 on this is 4 whole. So that's why you can write on this proper form, this this 4k upon 4 outside, and this is 4x square minus x minus 4 is the required, that is given now. See, this is the required answer which we can understand. Okay, k upon 4, that is a real value. So 4x square, even this is also correct answer. If you write, this is absolutely correct, and write in k form, then you can modify it. So x square minus, this is x, and here that is 4. So this is also this correct answer. Okay, now second part you will do yourself, homework. Third part, it's very simple, easily. What you write down first? The sum of the zeros equal to 0, it is given, and the product of the zeros equal to under root 5. Now again the required, what you write down? The required polynomial, we are required quadratic polynomial. What is that? X square minus the sum of zeros and x plus product of zeros. So now what you write here? See, x square minus, what is the product of the 0? 0. Sorry, sum of the 0. So write here 0 and x, and plus, what is the product of 0? Product of 0 is under root 5. Put here under root 5. So what you write? What is the correct form? X square and 0 means 0 into x, 0 only. So that don't write 0. Now directly plus under root 5. This is the answer. If, or you can write down in this form, any other quadratic polynomial which fits the given condition is, what is that? K in bracket x square plus under root 15, where k is real number. So this is done. and rest these questions you will do yourself in homework. Okay, the exercise is over. Thank you.